This is the last day of EOC practice test review. We'll keep reviewing in the coming days. So we have 2 more days to review after today, and then we're taking the EOC. It'll be here before you know it. So with that being said, we're going to go over the last 9 or so questions. We start with 21. It says, which of the following relations represents functions? Select all that apply. In order for it to be a function, you want to say x can't repeat. Okay? So if x can't repeat, that means it can't go to more than one thing. So if I have A, notice it goes to 15, we're good there. B goes to 14, but then C goes to 2 different things. So that means C shows up twice. So A is not a function. So then you go to B. Notice my x's don't repeat, but my y's do, and that is okay. So B is a function because your x's don't repeat, but your y's do. C, we do the vertical line test. I don't know if you guys remember this. You draw a bunch of vertical lines. If it only hits it at one spot, then it is a function. So all these vertical lines only hit the graph at one spot, so this is a function. Okay, D, if you think about this, this is a y equals mx plus b, so you're going to get a line like this. On y equals mx plus b, if I drew a bunch of vertical lines, they would only hit it at one spot. So D is also a function. E, if I try this, a bunch of vertical lines, it hits it more than once. So you see how it hits it twice. So that is not a function. So our answer is when it says select all that apply should have been B, C, and D on number 21. Number 22 says a student graphs f of x equals x squared and then graphs g of x equals x squared plus 5. Select the word that correctly completes a sentence. Hopefully you guys remember this. Plus 5 means I'm going to go up 5. If I would have said x squared minus 5, that would be down 5. If I would have said x minus 2 in parentheses squared, that would be right 2. And if I would have said x plus 2 in parentheses, that would have been left 3. Or left 2, sorry. But on this one, it is up 5 units. So that's number 22, should have been up. Number 23 says draw a line from each function type to the function shown in each table. If you notice this, we're dividing by 2 every single time, which means it's got to be exponential. And if I'm dividing, that means it's going to be decay. So the first one should have been exponential decay. The next one, notice my y values, they repeat, which means it's going to be a parabola. So the second one is a quadratic function. We know parabolas are related to quadratics. The next one, it's kind of confusing. If you convert these to decimals, though, that's 4.5 and that's 5.5. So I'm just adding 0.5 every single time. If I'm adding something every single time, that's a linear function, which means the last one has to be exponential to growth because I am multiplying, if you look at this, by 2 every single time to get to exponential growth. So that's number 23. That's how you match those up. Number 24, it says, which of the following statements best describes the linear model shown? Select all that apply. The number of days missed has no correlation to a student's final exam grade. Well, it kind of looks like they're correlated because the more days you missed, you kind of know what happens to your test grade, it goes down. So there is a correlation, so it's not A. B says a student with a perfect attendance is expected to score approximately 98% on the math final. So if I miss 0 days, my dot's up here on around 98%. So that makes sense. This is approximately 98%, which is good. C kind of contradicts B. If you have perfect attendance, you're going to get a 38%, so C is not true. D, it says for each day a student is absent, the student's final exam score is expected to decrease approximately 6 percentage points. So I go from 0 to 1. If you look at this, looks like it's kind of going down from a 98 to a 92. If I go to day 2, it goes from like a 92 to an 87. Day 3, I'm at like an 80. So if you kind of notice, they are going down by 6 percentage points. So that would be D. And then E, it says for every 6th day a student is absent, the student's final exam score is expected to decrease approximately 1 percentage point. If you miss 6 days, your test score goes from a 98 all the way down to a 62. So it's more than 1 percentage point, so it's not E. So your answers on number 24 should have been B and D. Number 25 says compare the graph. Guys, anytime they use the word minimum or maximum, it's going to be the vertex. So I notice this right here is the smallest value of my y, so that's my vertex. If they give you a function, you have to do x equals negative b over 2a. So I would do x equals negative 2 over 2 times 1, which gives me 2 over 2, which is x equals 1. If it's x equals 1, I'm going to say y equals, I'm going to plug in 1 to figure out what my y value would be. And when you do that, you get negative 4. So the vertex is at 1, negative 4 on that one, which means it has a minimum of negative 4. So that's for this function. G of x is for the table. So f of x, does it have a minimum of negative 1? No, that's at negative 4. So we know g of x has the minimum of negative 1 though, because that's here. Which means f of x has minimum of negative 4. That would be f of x. If it says 0 and it's in standard form, you probably want to factor it. Okay, so I'm going to say x minus 3, x plus 1 is what that factors into. And if I solve it, I get x equals 3, x equals negative 1 for my zeros. And then also the zeros here, do you notice they already found them? It's when y is 0. So my zeros on this one are 1 and 3. Those are my zeros for that function. So 0 at negative 1, well, if you notice, that would be the first function that we did right here. So that would be f of x. A 0 at 1 is g of x, if you look at the table. A 0 at 2 is neither function, because neither of them have a 0 at 2, and then a 0 at 3 would be both functions. And you can select both. So that's what your table should have looked like on 25. Number 26 says, which tables represent linear functions? Select all that apply. Linear means you're going to add or subtract by the same number every time. So when you do this, A, notice I am subtracting 3 every single time. So A is a linear function. D is not, because I'm dividing by 3. I don't want to divide, so it's not linear. B, I am multiplying by 2 every single time, so that's not linear. E, I'm adding 1.5 every single time, so that one's going to be a linear function. C, I'm adding 4 every single time, so that's also a linear function. And then F's kind of the tricky one. You're adding 3, but then you add 5, but then you add 7, then you add 9. Are you adding the same number every single time? No, so that's not linear. So your answer should have been A, C, and E. 27, if you graph it, don't forget you start with your y-intercept. So we're going to graph this first line, y equals negative 2x plus 3. So I start at positive 3 on the y-axis. That's my y-intercept. Negative 2 over 1 is my slope. So I'm going to go down 2, right 1, down 2, right 1. Notice they're counting by 2, so you have to be kind of careful when you're graphing this. So it looks something like that. The next one, you start at negative 2, and I go up 1, right 2, up 1, right 2, and you repeat the process. However, you clearly see that they intersect right here. If they intersect at that point, that is the solution to the system. So 2, negative 1 is the solution to the system, because that's where they intersect. Now, could you check your answer? Yeah, let's plug it in. So this is my y, this is my x. So I'm going to say negative 1 equals negative 2 times 2 plus 3. So I replaced my y value with the y that I said it was, and my x with the x at the bottom, that we said that's where they intersected. So negative 1 equals negative 4 plus 3. Negative 1 equals negative 1. It works for the first equation. If it's truly a solution to the system, it should work for both. So I'm going to plug into the other one. Negative 1 equals 1/2 times 2 minus 2. Negative 1 equals 1 minus 2. Negative 1 equals negative 1. So it works for both of them, which means you did the right thing, which means you got the right answer. 28, the following scatter plots show relationships between two variables. Draw a line from the correct correlation coefficient to the correct graph. If it has a strong positive correlation, that means the dots are really close together and it's going upward. So that would be 0.8. So the stronger it is, the closer it is to 1. If you notice, the other one that's going up would be B, but it's not as strong. They're not as bunched together. Okay, so that would be 0.43. The negative 0.14 would be down here. This one's going down, even though it's all spread out all over the place. And then negative 0.76 would be the one that's third, because it's going down and they're pretty close together, which means it's going to be closer to negative 1. The negative just tells you that's a negative slope. So that's number 28. 29 is the word problem. They give you this table right here for company A and company B, but then they also say, okay, Tony is reseeding the front lawn. The lawn covers 2,500 square feet, and grass seed is $15.98 for each 7-pound bag. Each pound of grass seed covers 150 square feet. So one bag is 7 pounds times 150 square feet gives me 1,050 square feet. So that is how much square footage each bag covers. So then if I take 2,500, my total yard, divided by my 1,050, I get 2.6. So that's how many bags I would need, but you're not going to buy 0.6 of a bag, so you're going to buy 3 bags of seed. So then I would take 3 times my price, which is $15.98, to figure out that I need $47.94 to cover / reseed the lawn. Then number 2 asks you to answer 3 parts, but it used the information from above. So it says, write an equation to model what it would cost if company A was hired. So if I go up to company A, if I want to write an equation, I'm probably going to write it into y equals mx plus b form. So with that being said, I need to pick 2 points, these two. I'll just do the first and the last, and I'm going to do slope of them. So I'm going to take 50 minus 750, so my slope is y2 minus y1 over x2 minus x1 over 2,000 minus 300. So I get 4,250 divided by 1,700, which equals 0.025. So that is my slope. So now I have y equals 0.025 x plus b. Well, I need to figure out what that b is. So let's plug in an x and a y. So I'm going to say 750 equals 0.025 times 300 plus b. Well, whenever you do this, you get 750 equals 750. So I would subtract 750. So my b is 0. So the equation is just going to be y equals 0.025x. So now if we scroll back down, instead of saying y equals, we're going to say the cost is equal to 0.025 times my square footage, which means the same thing. So y equals 0.025 times your s. So now company B, we're going to do the same thing, but now we're going to use their coordinates. So we're going to do 3,250 minus 16 over 1,500 minus 400. I get 1,650 divided by 1,100, which is 0.015. So I have y equals 0.015x plus b. Again, you got to figure out what your b is. So I'm going to say $16 equals 0.015 times 400 plus b. And again, I just took a coordinate from my graph. You can use any point that you want. So I'm going to say 16 equals, this ends up being 6 plus b, so I'm going to subtract 6. So my y-intercept is 10. So when I write my equation on this one, I'm going to say cost equals 0.15 or 0.015 s plus 10. So now that you have all of that, it says which company would cost Tony the least amount to landscape? Well, 0.015 times my square footage plus 10 is how much it costs for company B. So this is B, this is A, so 0.025 times 2,500 is how much it would cost for company A. When you do that, you get that company B is 4,750 and company A is 6,250. So which company is better? You're going to say company B because the fee is less because it costs 4,750. Says that how many square feet will both companies cost the same? So what we're going to do is, if I want it to be the same, I'm going to say, and like think about this, these are 2 equations. I'm going to set them equal to each other. So 0.025s equals 0.015s plus 10. I'm going to subtract 0.015s. You get 0.010s equals 10 divided by 0.01. S is 1,000 square feet. So at 1,000 square feet, they will cost the same amount. It says Tony's installing, and this is the hardest one I would say. Tony's installing a rectangular pool in the backyard. So we're going to draw a rectangle. The pool needs to have a length of 10 feet more than the width. So here's our width, but our length is going to be W plus 10 because it's 10 more than the width. This is the backyard, the whole backyard. So we're going to draw a big backyard as a square, with each of the sides measuring 5 feet more than 3 times the width. So 3 times the width means 3W, and then I add 5 to it to show 5 feet more. It says write an expression for the area surrounding the pool after the pool is installed. So I'm trying to find what I'm shading in green, the area around the pool after the pool is installed. So what you need to do is you need to find the area of the whole thing. So that would be 3W plus 5 times 3W plus 5 because it's length times width. And you can do the box method on this. So I would get 9W squared, 15W, 15W, and 25. So the area of the whole rectangle, or square in this case, is this. But now I'm going to put in a pool. All right, so now I'm going to take W times W plus 10. So it's W squared, 10W. So the area of the pool is that. So now I want to figure out the area of the green part, so I'm going to subtract the area of the pool from the area of the whole backyard, because now we've installed a pool in there. So 9W squared minus W squared gives you 8W squared. 30W, so that should be plus, minus 10W is going to give you 20W. And then I just have plus 25 at the end. So that is your expression that represents the area of just the part that has not been touched by the pool and is still left in your backyard. And that ends the review for our practice EOC test.